Sometimes when using the quadratic formula on some quadratic equation, we will end up with situations where we will need to express our answer as a complex number. These couple of examples will show that. The process remains pretty much the same as before, except now we're going to have to deal with square roots of negative numbers. All right, so here in this example, we have 7x squared minus 3x plus 3 is equal to 0. Here we have a is equal to 7, b is equal to negative 3, and c is equal to positive 3. Okay, let's go ahead and set this up. So we know that x will be of the form negative 3 plus or minus the square root of b squared, so 3 squared, negative 3 squared is 9, minus 4 times 7 times 3. And this is all going to be over 2a, or 2 times 7. Okay, we could simplify this further as 3 plus or minus the square root of 9 minus 4 times 7 times 3. So 4 times 7 times 3, that's 84. So we have 9 minus 84 all over 14. Okay, so now we have 3 plus or minus the square root of 9 minus 84, which is negative 75. And this is going to be all over 14. Okay, so what you'll notice here is we now have a negative number underneath our square root, which means we're going to have to use complex numbers. So the only way we can solve this is by introducing complex numbers. We can't solve this quadratic equation using real numbers. So if you were to ask to give all real solutions to this quadratic equation, you would say there is no solution. But if you're just asked to find all solutions, you can use complex numbers. So to do this, remember the first thing we do is we pull out an I, okay? So we have 3 plus or minus I times the square root of 75. This will be all over 14. And we can rewrite the square root of 75, or just we can write 75, I guess, as um, 3 times 25, okay? All right, and therefore we have 3 plus or minus, so we took the square root of 25, that's 5. So we have 5 times the square root of 3 times I, all over 14. All right, so that is the simplified version of our answer here. Nothing else really changes here other than the fact that we have complex numbers. The whole process is exactly the same. It's just as you're simplifying it, you have to deal with square roots of negative numbers. Okay, so let's see one more example of this. We have 3x squared plus 4x plus 5. So here, a is going to be equal to 3, b will equal 4, and c is equal to 5. So we have x is equal to negative 4 plus or minus the square root of b squared, or 4 squared, which is 16, minus 4 times a, which is 3, times c, which is 5. And this is all going to be over 2 times 3, 2a. Okay, so we can write this more simply as negative 4 plus or minus the square root of 16 minus 4 times 3 times 5. I believe that is 60. And this is all going to be over 6. Okay. So again, we could simplify this further as negative 4 plus or minus the square root of 16 minus 60. That'll give us negative 44. And this will all be over 6. Okay. So now next thing we do is we can pull an I out here. So we have 4 plus or minus I times the square root of 44 all over 6. And we can rewrite the square root of 44 as I times the square root of 4 times the square root of 11. And the square root of 4, sorry, and this will be over 6. And the square root of 4 is just 2. So this whole thing is going to be negative 4 plus or minus 2 times the square root of 11 times I all over 6. And we can simplify this one step further by pulling a 2 out of the top here. All right, so if we pull a 2 out, sorry. Okay, this will simplify further. 2 over 6 is 1 over 3. So this will just become negative 2 plus or minus the square root of 11 times I over 3. And there's our answer.